children, welcome to your home school. This is your next session of your triangles. Children, this is your part 4, not part 3. Don't be confused by seeing the third problem here. How many of you observed there? In part 3, I have changed the third problem question. What is that question here? Observe here. AM by MB, AN by ND. How many of you observed there? So, in order to match the next 3 problems, I have changed the question there. If you want, you can check in your description box also. Okay. So, now once again I am repeating the third problem by changing the ratio. This is actually our textbook question. Okay, let's see carefully. What's this question? Same question. Only the change is denominator change. AM by AB, AN by AD. This is one corollary. Do you remember? So, how to prove this is your question. So, what's given here, children? In figure, if LM is parallel to BC. So, what do I can write here? A remark. It indicates parallel. LM is parallel to CD and LN is parallel to CD. LN is parallel to CD. Prove that AM by AB is equal to AN by AD is your question. See here, in our last part, what we have done is not wrong. According to that question, that method and the proof what we have proved is correct. Okay, let's see the third problem now. How to start your solution? Given, what given we need to write now? LM is parallel to CB and LN is parallel to CD. What I need to prove, children? Here, to prove. TP means to prove. AM by AB is equal to AN by AD. Okay. So now let's start our proof. How do we start? If lines are parallel, what do you remember? Basic proportionality theorem. That is, if lines are parallel in a triangle, then the sides are in proportion. So first let us consider. What we need to consider here, children? Any one triangle you take. Consider triangle ABC. Where in this triangle, what did they give us? LM is parallel to CB. Okay. By basic proportionality theorem or Thales theorem. What you can say, children? If this line is parallel to this line, then these two sides are in proportion. That means AL by LC is equal to AM by MB. Mark it as first equation. Okay. Next, consider another triangle. What do you have? What is the another triangle here? ADC. Consider triangle ADC. In this, which are parallel here? LN is parallel to CD. Okay, if you see these two parallel lines, what do you remember? If these two lines are parallel in a triangle, then these two sides are in proportion. That means AN by ND is equal to AL by LC. That is your second equation. Some children may get a doubt. Ma'am, we know the corollaries. Can't we do directly we can apply? Yes, you can apply. But when they say there use corollary, you can use. Otherwise, directly go with the BPT. So now, what I can do here? Compare these two equations, children. This ratio and this ratio is equal. So what you can write? These two you can write equal. Do you know this? A is equal to B and C is equal to A. So A equal, you can equate these two. So how do you equate? On comparing or equating, you can write comparing equation 1 and equation 2. What you are going to get here, children? On comparing, I will write it as AM by MB is equal to AN by ND. Now, we have stopped in our last session up to here, right? So, if your question is this, you can end up here. But your question, denominator is different. So, what we need to do in order to change the denominator? So, I am going to do the reciprocal. Do you know reciprocal? Why am I doing? Look here carefully. Numerator am and numerator an is same. Whereas when I need to change the denominators, okay, so how can it be changed? If you bring that to the numerator, then you do add 1, do LCM, denominator won't be changed at the time, numerator will be changed. So do the reciprocal and change the denominator. So look here, observe how we are going to get. So let me do the reciprocal of the equation. Reciprocal of the equation, what is that here, children? MB by AM is equal to ND by AN. Still, I didn't get the answer. Then what I need to do? Let me add. Adding 1 on both sides. For corollary also we have done the same thing, children, here. Adding 1 on both sides for what? MB by AM plus 1 is equal to ND by AN plus 1. Now what we need to do here? We need to do the LCM. So AM and 1, what is your LCM? AM. This will be MB plus multiply AM here. AM is equal to ND plus, see, this is the denominator, nothing there. AM and 1 LCM is AM. So AM you need to multiply MB plus AM by AM. And here also AN and 1 LCM is AN. So AN multiply for 1 ND plus AN. So now observe here from the figure, children. MB plus AM. What is MB plus AM? It is nothing but AB. It is nothing but AB. So that will be AB by AM is equal to ND plus AN. ND plus AN is nothing but the big line AD. AD by AN. So now observe there. Again we did not get the answer. So now what we need to do? Now again do the reciprocal of the given ratio. Do the reciprocal, what you are going to get here? AM by AB is equal to AN by AD. This is the ratio we need to prove there. Therefore, finally what you are going to write here? Hence, it is proved. Geometrical problems, if anything asks there, prove that? Yes, I proved it. Okay, how do you write that statement? Hence, it is proved. So look here, 7th problem, children. Using Theorem 2.1, you need to prove. What is Theorem 2.1? It is a basic proportionality theorem. And they gave a hint for this problem. As you already have done in your 9th standard, this proof it seems. Okay, where did you do this? By midpoint theorem, where you have seen no in 9th standard. There you have done this type of problem. Okay, so forget about the past. Let's come to the present. So let's learn once again. See the question here. Prove that a line drawn through the midpoint of one side of a triangle. Stop. So what do we need now? We need a triangle. So what do I do here? Let me do a triangle. Observe carefully, children. A, B, C. Again, prove that a line drawn through the midpoint of one side. Observe the question carefully. Draw a line such that midpoint of one side. Okay, for this side, if I take this as a midpoint D. Draw a line. How I have to draw? Which way I need to do? Let me read this. Of a triangle parallel to another side bisects the third side. Oh my God, what is this question here? One side, that line divides the midpoint, they said, means It divides equally. One side it is dividing at the midpoint. Another side it is making parallel. And another side, what does it do? It bisects the third side. What do you mean by this? You need to prove that this line bisecting the third side. So let me draw a line here. I don't know. Here it is a midpoint, children, means AD is equal to DB given. And DE is parallel to BC given. You need to prove that AE is equal to AC. So observe here carefully, there is nothing to confuse. First understand the given question mark. What is that? Consider a triangle and draw a line which is drawn from midpoint of one side and is parallel to another side, bisecting the third side. Prove that it is bisecting. Okay, that is bisecting, they did not give us. Okay, these two given, you need to prove this side E bisecting AC. Bisecting means what? You should prove AE is equal to AC. So let's start our solution here. Given, what is given here? They have given a triangle, but we have marked their ABC. Given a triangle ABC, and what did they give here, children? AD is equal to DB. Yes or no? One more point given. What is that? DE parallel to BC. So, what is given here, children? ABC is a triangle and AD is equal to DB. DE parallel to BC. DE is a line which is given such that DE is bisecting AB and is parallel to BC. So now, what you need to prove in this problem? You need to prove that E point bisects AC such that A is equal to EC. You need to prove. So let's do proof. What is given here, children? AD is equal to DB. So in triangle ABC, given AD is equal to DB. So now send this side, children. Do you know how to send this? If it comes this side, it will divide. So what it will be? AD by DB is equal to 1. Okay. Mark this as first equation. Given ratio, I made it first equation. Now, what is given here? DE parallel to BC. They have given DE is a line parallel to BC. So now, by this given you can write, by basic proportionality theorem, if those two parallel, then the ratios are in proportion. So by BPT, what you can write here? Apply BPT, children. See there and apply BPT. AD by DB is equal to AE by EC. AE by EC. Okay. Now go back. Look here. What is AD by DB? 1. Let us substitute here. Substitute equation 1 in above. Equation 1 value in above. That means 1 is equal to AE by EC. This AD by DB how much? 1. That 1 I have substituted here. What did you got here? 1 is equal to AE by EC. Now did we complete? No. What we need to do still? This denominator send other side. That makes EC is equal to AE. That's your answer. Where is answer? AE is equal to EC. That is EC is equal to AE. Anything you can rewrite that side, this side, no problem. EC is equal to AE or AE is equal to EC, same. Therefore, what you can write here, children? Hence, it is proved. So, what it is proved here? If these two are equal, what you can say? Therefore, E is a point which is bisecting AC. If it bisects, AE is equal to EC. Let's see the 8th problem here, children. using theorem 2.2. What is theorem 2.2? Converse of basic proportionality theorem. What is the statement here, children? If ratios are in proportion, therefore the lines are parallel. So now prove that the line joining the midpoints of any two sides of a triangle. So immediately what we do here, let's draw a triangle A, B and C. Okay, ABC is a triangle. What did they ask here? A line joining the midpoints of any two sides. So we have to draw a line such that from the midpoints of any two sides. So let's consider AB side and AC, two sides midpoints. So let's mark the midpoint here. Okay, so let's mark this D and let's mark this E. So now read again. The line joining the midpoints of any two sides of a triangle is parallel to the third side. What is the last line? We need to prove that this line is parallel to BC. How can we prove, children? By using converse set. So if ratios are in proportion, if we are able to prove, then we can say that they are parallel. So let's start here. Let's start a solution here. With the given data, we need to start. What is given here? Given triangle ABC. Okay, triangle ABC. Triangle is given. Sorry. Okay. Okay, look here, children. Solution. Given triangle ABC. They have given us a triangle. We have marked ABC. Not only ABC, any letter you can write there. PQR, LMN, any letters you can use. Okay. So, given triangle ABC. So, still what they have given? Midpoints of two sides. There is a line drawn. Midpoint of two sides. So what do I write here? D. Point D is midpoint on AB line. On AB line segment. Okay. So now if D is midpoint on AB, what you can say? AD is equal to DB. Yes or no? Now send this DB this side. That makes AD by DB is equal to 1. Mark at first equation. Okay, I have taken only 1 point. So now let's consider another point. What is another point? E. E is midpoint on AC line segment. Okay, E is midpoint on AC. So what you can say, if E is midpoint, how can you say midpoint? AE must be equal to EC. AE is equal to EC. Now send the CC this side, children. AE by EC is equal to 1. Again, second equation. Now compare these two equations. What is common? When you are going to equate, 1 is common. If this equal to 1 and this equal to 1, you can eliminate 1 and you can equate these two ratios. On comparing equation 1 and equation 2, we get, what do we get here, children? AD by DB is equal to AE by EC. Observe one figure what we have wrote here. AD by DB is equal to AE by EC. What do you remember? Yes, the ratios are in proportion. If they are in proportion, what you can say? Therefore, DE line is parallel to BC. So, what you can write? Therefore, by converse of BPT. By converse of BPT, I can say that DE line is parallel to BC. See here children, if in given data, if you want, you can write here DE is a line. DE is a line segment joined from the midpoints of other two sides. So here, once again I am going to repeat here. D is a line joined from two sides midpoints here. So if D is midpoint, what you can say? AD equal to DB. If E is midpoint, A equal to EC. So you have made into two equations. On comparing, one is same. So you are equating these two ratios. If you equate, you can remember that the ratios are in proportion. That is converse of BPT. If ratios are in proportion, the line is parallel to the third side. Okay. Ninth problem here. ABCD is a trapezium. Do you know trapezium, children? Let's draw the trapezium here. Okay. This is a trapezium. Let me mark it. A, B, C, D. ABCD is a trapezium in which AB parallel to DC. So, how do you indicate, children, parallel? AB line, AB is parallel to DC. Okay. And its diagonals. How do we get diagonals? If we join, we are going to get the diagonals. So, now I have drawn two diagonals here. And its diagonals intersect each other at the point O. Where they are intersecting? Here. Mark a point O. Show that AO by BO is equal to CO by DO. So understand the question carefully. Given it is a trapezium, AB is parallel to DC and diagonals intersecting at point O show that AO by BO is equal to CO by DO is your question. So let's start here. Solution. How do we start here, children? With the given data. Data, always you have to start with the data. Given. What is given? Given ABCD is a trapezium. Okay, ABCD is a trapezium. And still what they have given here? AB parallel to DC. Okay, one more line given. Diagonals. Diagonals. What are diagonals here, children? AC and BD intersect at point O. Okay, intersect at O. What we need to prove here? We need to prove that AO by BO is equal to CO by DO. We need to prove. Okay, so let's start your proof. How do we start your proof here? So I'm going to say you techniques to remember this problem. See here, children, this problem can be solved in many ways. But I consider two triangles here. On one side only I'll consider and try to prove here. So observe the triangles, what I'm going to prove. So let me draw the triangle here. Okay, what is that triangle? ADC. Can you see the triangle ADC? You can see now. So now one more triangle, that is DBA or ABD. See, ADC and ABD. These are the two triangles I am going to consider and I am going to prove. Before starting the proof, I need to construct small line here. What is that line here? I may draw a line EF. Okay, in your construction part you have to write here, children. So let me write here construction. What I need to write here? Construction. Draw a line EF parallel to AB and also parallel to DC. See, this line is drawn in between two parallel lines. Then I can say that this line is parallel to this line and also this line. So what do I can say here? Parallel. This is also parallel. So now the same thing I am drawing in this triangle. So immediately you remember something if I draw. What do you remember? Yes, basic proportionality theorem. You are going to remember, right? If this EO is parallel to DC. Yes, children? Now here also same thing I do here. OE. This is parallel to this. Again you can remember the BPT. See, in exam you should not do like this. You should not split. So for understanding or writing the ratio if you want, do with the pencil. In exam also do with the pencil. Afterwards clean up. Right? So now in this trapezium I am taking these two triangles in order to prove that ratio. Okay, first let us consider this triangle. Okay. Consider triangle ADC where EO is parallel to DC, children. Okay, EO is parallel to DC. So if it is parallel, what you can remember? By basic proportionality theorem. By basic proportionality theorem, what you can say? AE by ED is equal to AO by OC. AE by ED is equal to AO by OC. Okay, mark this first equation. So now let's take the second triangle here, children. What is the second triangle? Consider triangle DAB where EO is parallel to AB. Parallel we have done by construction. We are saying that these two lines are parallel. If they are parallel, I can apply BPT. By basic proportionality theorem, see here, your vertex is here, children. Your triangle is reversed, right? So from here only I will continue. That is DE by EA. Children, are you able to see it on the figure? DE by EA is equal to DO by OB. Mark it second equation. There you go. Here you are going to confuse a lot. So now see here. AE by DE. Here DE by AE there. Yes, are you able to follow here? Same ratio but reverse there. This is different ratio, right? So now what you are going to do? Do the reciprocal of second equation. Do the reciprocal of above equation. What you are going to get here, children? You can write EA or AE same. AE by DE is equal to OB or BO same, no? BO by DO. Now mark this third equation. Okay. Now compare these two equations, children. AE by DE, AE by DE same. Don't be confused. Ma'am, here ED there. ED or DE same. AE by ED and AE by ED both are same. So if these two are equal, on comparing, what you can write? You can skip this and this. You can equate these two. That is. So look here, children, carefully. On comparing. Comparing equation 1 and 3. Equation 1 and 3. What you are going to write here? AO by OC is equal to BO by DO. So look here, children, OC there. If you want, you can rewrite this as CO. AO by CO is equal to BO by DO. So now compare your proof. Same there? No, still something changed. What is that? This BO should come here. This CO should come here. So then exchange. Why late? Let's exchange. This BO numerator, if it comes other side, denominator. This CO, if it goes other side, it is multiplied to the numerator. So let's cross multiply. Only BO CO, not AO DO. Okay? AO by BO is equal to CO by DO. Hence it is proved. That's it. AO by BO is equal to CO by DO. AO by BO is equal to CO by DO. That's it. This is the thing we need to prove here, children. Let's see the 10th problem here, children. It is similar to the 9th problem with a little change. Okay. So what is this question here? The diagonals of a quadrilateral ABCD. What do you mean by quadrilateral? It is having 4 sides. Okay. So take a quadrilateral ABCD, intersect each other at the point O. So I have taken a quadrilateral nearer to trapezium. Why I need to prove it as a trapezium? I don't know it is trapezium or not, secondary. But I have drawn my figure little similar to trapezium. It is actually a quadrilateral. Trapezium is also one of the quadrilateral. Right? So draw a quadrilateral, mark A, B, C, D. Diagonals intersect each other at the point O. Where are the diagonals? Observe here. AC, BD are the diagonals intersecting at point O. Show that AO by BO is equal to CO by DO. Do you remember this ratio? Just now we have proved, right? So same ratio we have here. What to do with this ratio? They have given the ratio. I need to prove that this quadrilateral is a trapezium. First thing here, children, when I can say it is a trapezium, when I was able to prove AB is parallel to DC, then I can say it is a trapezium. So now let's start our solution here, children, with the given data. What is given here? Given ABCD is a quadrilateral. Okay. So now diagonals AC and BD intersect at point O. Diagonals AC and BD intersect O. And still what they have given? AO by BO is equal to CO by DO. So in your last problem, do you remember what we have done? We have sent BO this side, CO this side. Do you remember? So now also we do that only. So let's interchange this one. AO by CO is equal to BO by DO. Have a look here. Just see there. AO by CO is equal to BO by DO. Why I have made like this? You will be getting clear next. Now next step. What is your next step here, children? Construction. Is there any construction? Yes. How can I prove without any line? So let me draw a line EO, which is parallel to any one side, children. You can take any one side of a triangle. In your last problem, we have taken this triangle and this triangle. No? So for any triangle, you can take this line. So which triangle you want to consider? So let's consider ADC. Okay. So your mind have to see this picture on this quadrilateral, not separate always. Okay, this figure you need to observe here. So observing little it might be difficult. So I have drawn your rough figure down. So please make sure that you have to clean up in your exams these rough figures. See here carefully. ADC. ADC. This is the triangle you have to observe on this quadrilateral. So observation I have drawn here, but you try to clean up in your exam. If you do like this rough figures, you have to clean up. Only for solving problem like this, if there, definitely you don't do any mistake. Okay. So now let's see here. So construction, what we have done, EO is parallel to DC. So if they are parallel, immediately what do you remember, children? The ratios are in proportion. By which theorem? By theorem 2.1, that is basic proportionality theorem. So construction I have done EO parallel to DC. So what I need to prove here? What you need to prove? ABCD is a trapezium. To prove ABCD is a trapezium. Okay, so now let's start our proof here, children. So how do we start our proof? Given. What given here? If you want, you can mark this ratio here. AO by CO is equal to BO by DO. Let's mark it. First equation, and you can write this with a given. Okay, second thing what I need to do here, we have done construction such that EO is parallel to DC. In triangle, which triangle it is? In triangle ADC, I know EO is parallel to DC. Therefore, what can I say here? By basic proportionality theorem, what you can say? So if EO is a line parallel to any one side of a triangle, then it divides other two sides in proportion. That is AE by ED is equal to AO by OC. So now try to compare here, children. Try to compare here carefully. Any ratio is looking similar? Yes. What is that ratio? AO by CO. AO by CO is common. So what you need to do? Let's compare these two. On comparing 1 and 2 equation, what you can write here, children? AO by CO, AO by CO is common. So directly I will write it as BO by DO is equal to AE by ED. So observe here, where is this ratio? BO by DO. Okay, is equal to AE by ED. So can you see a new triangle? Look here, which triangle we got here? So like this equal to this and this equal to this given. Observe here carefully, this is D and this is A, this is B. So if I say this BO by DO, you can say, children, DO by BO or BO by DO is same. So BO by DO is equal to AE by ED. So another new triangle, ratios are in proportion. If ratios are in proportion, what you can say? By converse of BPT. Therefore, from triangle ADB, in triangle ABD, if ratios are in proportion, so by converse of BPT, I can say that EO is parallel to AB. So now look here, children, EO is parallel to DC. Now EO is parallel to AB. So what can you say here? Directly you can say, first we have taken EO is parallel to DC. Yes. Now what we got after proving EO is parallel to AB we got. So finally what you can say? This is parallel to this and this is parallel to this. Finally this is parallel to DC. So how do you write, children? EO is parallel to AB and EO is already parallel to DC. Therefore, by converse of BPT, AB is parallel to DC. If AB is parallel to DC, what you can say? Therefore, ABCD is a trapezium. Therefore, ABCD is a trapezium. Okay, this is the thing we need to prove here, children. So once again, have a look of this important problem. See here, last 4 problems. That means what we have done in this session are all very important. If you try to do today now itself 3 times, then you will be perfect with these problems. So if you postpone and you won't understand these all problems. So once again, look here, the diagonals of a quadrilateral diagonals of a quadrilateral AC and BD are intersecting at a point O, such that AO by BO is equal to CO by DO, given some ratio proportion given. What you need to prove? Prove that this ABCD is a trapezium. When I can say this is a trapezium, when the opposite sides are parallel, then I can say it is a trapezium. And given what we have written here, given ABCD is a quadrilateral and the diagonals AC and BD intersect at O, and they have given a ratio AO by BO is equal to CO by DO. So please put a star mark here. Why? This step is very, very important for you. If you forget this, you won't get this full problem. So what did we do here? We have interchanged the CO here and BO here. It makes AO by CO is equal to BO by DO. What we have done a construction, EO is parallel to DC. See here children, I have taken this triangle. If you want, you can take this triangle. In order to prove, you will get this triangle and this line will be parallel. Okay, any triangle you can choose your wish, right? So now I have taken EO such that it is parallel to DC. If EO is parallel to DC, immediately what you remember? By basic proportionality theorem, AE by ED is equal to AO by OC. So first in the proof, we have taken the given ratio first. Then when EO is parallel to DC, what we got by this triangle, we have written this ratio. On comparing these two ratios, check whether any ratio is common. Yes, AO by CO and AO by CO is common. Then equate these two. If you equate and compare in your figure, you can see another new triangle and this line is parallel to this. Another new triangle. What you are going to get here children? These ratios are in proportion. If they are in proportion, then these two lines are parallel. That is OA parallel to AB we got. First, what we have constructed, OE parallel to DC. Now, what we got proof, OE parallel to AB. Finally, this OE is a line parallel to this and this. So, what happens? If this is parallel to this and also this, therefore, you can skip OE and you can say AB is parallel to DC. If AB is parallel to DC, then what happens to this quadrilateral? It forms a trapezium. Therefore, ABCD is a trapezium. With this, we are going to end our session. This topic is very important, children. If you have missed any of the videos of this triangles, you can go to the description box below the link and you can watch the other videos which you have missed. Okay, keep on watching, children. We are going to meet in our next video. Thank you.